Hi, and welcome to this short video introducing the concept of internal energy. The internal energy is an important concept in thermodynamics, and, as a state function, we can undertake calculations with the variable with relative ease. However, the actual physical nature of what the internal energy is often poorly understood, particularly on a bulk level. However, our molecular explanations of thermodynamics helps us to understand this important concept. You will recall that all molecules have energy levels associated with them. These energy levels are associated with the motions in the molecules, or electronic excitation. Translations have the lowest spacings between the energy levels, with molecular rotations next lowest spaced and vibrations with slightly bigger spacings, before the very large spacings of electronic energy levels. We have already mentioned the link between these energy levels and the Maxwell-Boltzmann distribution of speeds, or kinetic energy, of particles. It follows that if a system has a higher kinetic energy of the constituent particles, then it will also have a higher internal energy. This logical step is true and helps explain the units of R, the gas constant, and Kb, the Boltzmann constant, as we can conflagrate the motion of the molecules in a system to the thermal energy of that system. When we use R, we are looking on a bulk level per mole of the particles. However, when we use Kb, we are looking on a molecular level per particle. So when we multiply either of these constants by the thermodynamic temperature in Kelvin, we are getting a thermal energy for our system. However, this thermal energy, this motion of molecules, is not the only contributory factor. Yes, this thermal motion is an important contributory term. The more motion the particles in the system have, the higher the populated energy level, and the more thermal energy is contributed to the internal energy. We also have to consider the inter- and intramolecular bonding in the system, as energy is also held in these bonds. Again, thinking of this on a purely gut level, it makes sense that a gas, even a real gas, where the intermolecular bonds are broken, has a different internal energy to a liquid at the same temperature. These intermolecular bonds mean it is difficult to quantify the internal energy of a system other than an ideal gas, and so we mostly look at a change in that system, making use of internal energy being a state function. So, the change in the internal energy is the difference between the internal energy of our system in its final state minus the internal energy of our system in its initial state. We do not care how this change was instituted, just that it happened. It is rare to undertake calculations on internal energy unless they are linked to experiments with bomb calorimeters, for example, but the concept is fundamental to our understanding of thermodynamics. Elsewhere, we will look at the internal energy of an ideal gas, but for now, I hope that you have found this video useful and you now have a better understanding of what is meant by the term internal energy. I look forward to sharing other thermodynamics videos with you, and if you have any questions, please do not hesitate to contact me.